that's sort of irrelevant to what you're asking for. How soon do you disagree with whether the final time period?
Okay, so what is on the schedule for today is the beginning of lesson 3. But I didn't quite finish up lesson 2 last time, and I sat in bed last night debating about whether to just move on to lesson 3 or to try to wrap up lesson 2. I've decided I'm going to just spend a few more minutes talking about lesson 2. If I get so that it's 15 minutes from now or so and I'm still in lesson 2, I'm just going to stop and we're going to move on to lesson 3. But we were talking about the CN statement last time. Let me first of all say that I'm speaking very informally when I say the CN statement because I mean, it looks like that kind of implies that CN is the action word there, right? If I call it a CN statement, that kind of implies that CN is the thing in that statement that's doing the work. And the thing in that statement that's doing the work, as we talked about before, is the extraction operator, right? So that's not a huge deal. I just have to say that as kind of a disclaimer, you know, in case someone's sitting out there judging me based on whether I'm using correct terminology or not. You know, technically speaking, I probably shouldn't call it a CN statement. But that seems to be the most convenient thing to call it, so that's what I will do. Really, I suppose what I should say is we're talking about the extraction operator. And at one level, the extraction operator, the CN statement, is very, very simple. Okay, as long as you stick to the user just entering one value and hitting the enter button, it's extremely simple, right? You just say CN and then the name of a variable. It stops, the user types something in, and whatever the user types goes in the variable. Done. Okay? For better or for worse, it's not that simple, though, because you can set it up so that the user can enter multiple things before they hit the enter button, or even multiple things on multiple lines before you ask for go to the next CN statement. And really what's going on there is that eventually we're going to talk about reading data from files instead of reading data from what the user's typing. And we use the extraction operator for that too. In that case, there is no concept of the user typing something and then hitting the enter button. Okay? So that's why this gets a little complicated. Let me just do a couple of examples. Suppose we have that statement, and let's assume that hours and pay rate are both ints. I guess I should be explicit about that. Okay, and then let's say that the user types space. I'm actually going to do this tilde symbol I'm going to use to represent a space. So let's say the user types space, 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 78, space, 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 49, space, 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 and then enter. Oops, that's, okay, can you pretend that those are spaces? Okay, so there's spaces before and after the 78 there. Okay, so let's go through what's going to happen when this CN statement here is executed. First thing that happens is I'm working on this extraction operator here, and I go and look in the input stream. There's a bunch of spaces. I skip over all the spaces because that's what the extraction operator does. Did I just say insertion operator? Anyway, I meant extraction operator. And then I read 78 into the variable hours. Right? Okay. Then the next thing that happens is I've got another extraction operator and another variable. So I start reading again. I skip over all the spaces, and then the 49 goes into the variable pay rate, right? Okay. So now I am done executing this statement. What's left in the input stream? Actually, more than just backslash n, right? There's 4 characters still left in the input stream, right? 4 spaces and the new line character. So the next time we execute a assignment state, the next time we execute the extraction operator, what's going to happen? Are those 4 characters that are left in the input stream, are those going to mess us up? Go ahead. So actually, the new line character is included in what we call white space, and the extraction operator skips over white space. So the next time we have an extraction operator, it's going to skip over all those spaces and the new line character because that's all white space. And so, from our perspective, it's going to look like everything's just behaving normally. It's not even going to. We're not really going to be aware of the fact that there were those 4 extra characters left in the input stream. Okay. However, and this is something that I don't talk on very much in lecture because of time, but you will need to read about it in the text. There are some other statements that we can use to get input besides the extraction operator, and they don't skip leading spaces. So you do have to be aware of what's going on here. Okay, you have to keep track of the fact that if I were to, after this statement, if I were to have another statement that didn't skip leading spaces, the first thing it would read would be a space, and not whatever the user's typing in next. So that's actually a fairly common source of errors when you're writing programs. Okay, I'm going to go on from that. Anybody want to ask a question about that? I'm aware that this is a little bit abstract, and I'm eager to get to let's do something with it. But just like a little bit more I need to do first, and then we can dive into something. Yeah. Okay, so the question is, would that work the same way if those were string variables or double variables? And that's a great question, because my next thing I want to talk about is how does the extraction operator work with different types of variables over there on the right side. Okay, so in this case right here, when I say cin hours, C++ knows that hours is an integer variable, so it's going to look for one integer. And it's going to read an integer and then stop. Okay, so the way that C++ knows to stop in this case is that I get to this space here, and I know that space can't be part of the integer, so it just stops. Okay, so the same thing is essentially true for any type. The extraction operator is going to read one of whatever type that variable is over there on the right, and then stop. Okay, so really what's going on is that there's not just one extraction operator, there's a bunch of extraction operators. There's a different extraction operator defined for each type of variable that's on the right side, because it's going to do different things if it's an int or it's a double, right? So let me give you an example. Let's suppose the user types, hit the enter button, hit the enter button again, 3 spaces, 13.72 W. Okay, I'll just leave it at that for now. And then let's say that I have the following code. Cn, x, ch, I. Now, just x is a double, ch is a char, I is an int. Okay, that's kind of conventional way of writing variables. So during lecture, if I use x, you can just assume that's a double variable, and if I use I, you can assume that's an int variable. And if I do ch, you can assume that's a char variable. Question? Well, so I'm not done with my example yet. I'm saying let's assume that this is the statement that's being executed, and this is the what the user types in. And let's see what happens, okay? So, what's going to go into the variable x? 13.72, right? Because when I'm reading along, I read the 1, I read the 3, and the next thing is a decimal. Can that decimal be part of a double? Yeah, so I just keep going. And then a decimal, and then the 7, and then the 2, and then I see the next thing is a W. Can that be part of a double? No, so I know I'm done reading my double, and I stop. So x, in this case, is going to be, actually, I'm going to draw a picture. Oops. X is going to be 13.72. Okay. And then the next thing that, the next thing that happens is I'm reading a character variable named ch. So what's ch going to turn out to be equal to? W. Okay. And now the next thing I'm going to do is read an integer. So what's going to happen when this program is executing at this point? It's going to stop and wait for the user to enter something. There's nothing left in the input stream. We've read everything from the input stream, right? I mean, technically, I suppose it's not possible for W to be the last character in the input stream. It would be a \n, right? Because the user had to hit the enter button. Right? But same thing. When I am executing the extraction, I'm trying to extract an integer. I look in the input stream. There's just a new line character there. So I skip over the new line character, and then I have to wait for the user to type something else. So at this point, after I execute this statement on this input, well, let me rephrase that. I can't finish executing this statement yet because I don't have enough input, right? I'm just going to be, the computer is just going to be sitting there waiting for more input. Okay? Let's say, though, that we have, let's try a different example. CN, I, CH, CH. Why don't you take 1 minute and tell me what the contents of I and CH are going to be when this is done? Okay, so someone tell me what you think is going to be in the variable I. 13? Did anyone get something different? Okay, so yeah, that's right. Well, the first thing I read is an integer, and so the first integer in here is going to be 13, and when I get to the decimal point, I stop because the decimal can't be part of an integer. Okay? What's going to be stored in CH when I'm done here? Okay, so I got half saying decimal point and half saying 7. Let me be clear. I'm talking about when I'm completely done executing this entire statement. So if I were to say cout CH after this, what would come out? Okay, let's run through it. Okay, after I read that 13, the next thing that happens is I read one character and I store it in CH. What character is that going to be? No, I just read the 13, so the next character is the decimal point, right? So I'm going to store a dot there. I don't know if you can even see that, but there's a dot there. Okay? So now I'm done reading the first CH, and the next thing it says is read another character and put that into the variable CH. Okay, so what character am I going to read now? 7. And what do I do with the 7? Store it in the variable CH. So it just overwrites what was in CH before, right? So the dot goes away, and instead I have a 7. Well, whenever you put something into a variable, whatever was there before is just going to go away. Right? If I have an integer variable that's equal to 7, and I say let that variable get assigned to 13, well, the 7 is going to go away and get replaced by a 13. That's just how variables work. Okay? Any questions about that? Yeah. With variables of type char, which I'm assuming CH is here, you can store punctuation marks, letters, digits, and some special characters. So that's it. A question there? Right. Correct, yeah. So the question was, when you're reading a character, is it the case that you only read single digits? And the answer is yes. Question?
Well, you say that the decimal point is replaced with the 7, right?
Yeah.
So then what is it going to read out?
So the question is, the decimal place was replaced by 7, so what is it going to read out? So I think what you mean, I think what you're asking is, what if I have a cout statement here? What's going to get printed? Well, when I see cout ch, what do? I go find the variable ch and see what's in it, right? What's in the variable ch? 7. So 7 is going to get printed out.
So that's the extract operator is basically reading that the integer 13 is going to go with the character, the decimal point. So for instance, the character counting up the decimal point is going
I don't think that what you said was correct, so I'll just say it the correct way, okay? I'm reading an integer, and the integer I read is 13. And so that goes into I. The next thing I'm reading is a character. The next character in the input stream is a dot. So the dot goes into the variable ch. I'm reading another character. The next character in the input stream is 7. And so the 7 goes into the variable ch. That's it. Okay. I'm ready to stop talking about this and start talking about our next topic. Let me get rid of this. Actually, no, I don't think I'm going to even need that. So I'm going to switch over to Dev C++. I really do intend to use Visual C++ in here sometime, but this is just so easy that I can't bring myself to change quite yet. Okay, so I need to share my desktop, and I need this to go away. Okay, so you should recognize this program. Do I need to make that bigger? How many people want that to be bigger? Bigger, okay. Say again? I'm going to be playing around with this, so I guess, I don't know, it's going to be pretty hard to take notes on what I'm about to do because I'm going to be like moving code around and stuff, so you might want to just hold on and wait for the lecture notes on this one. Let me make the font bigger. Okay. All right, this is actually not exactly what we talked about in class. This is something that you'll find in the lecture notes that I didn't quite get to when I did the lecture. And basically, what we did in class was we did not ask for the user to enter the pay rate. We just used 10 as the pay rate, right? So all I'm doing here is I added this little feature where instead of always having the pay rate be 10, I ask the user what the pay rate is, and then use that in the expression instead of 10. Question?
So if the user entered like 9.5 for the pay rate, you wouldn't be able to do it.
Correct. Right now I'm just sticking to ints, which probably doesn't make a whole lot of sense, right? I probably should use a double, but I didn't. I used int. And so if the user entered 9.5 right here, what would happen? That's a great question. A little bit of a digression, but let's talk about it. What's that? The pay rate would just be 9, right? Question? Right. That employee wouldn't get that 50 cents per hour that they deserve. So this is how you write your program if you're the boss and you want to skim off the top, right? Question in the back. 0.5 would still be sitting there in the input stream. If there was another CN statement, the next CN statement would pick it up, yes. There isn't one, though, so the program's going to be done executing, and then the input stream's just going to go away. No. Okay, so the question is, if you made it a double, I'm going to turn it around a little bit, would it still work if you didn't enter a decimal point when you entered the value? And the answer is yes, it would still work. Okay, you can just, 47 is a valid thing to enter for a double value. Okay. All right, so what I want to do is I want to give my employees a bonus if they work more than 30 hours. Okay, I'm trying to encourage them to, work more. So if they work more than 30 hours, I want to give them a $100 bonus. Okay? How am I going to do that? I'm going to need an if statement, right? So where should I put it? Okay, now let's pause for a second here, okay? I'm introducing something new, okay? But if you've never heard of an if statement, that doesn't mean you can't participate in this discussion because you know what the word if means in English, right? All we're doing here is we're talking in English for now. And ideally, that's how your C++ programs are going to read. They're going to read as much as possible like English. But so where should the if statement go? Where it's flashing? After the input hours worked. So that's the question. Do I want it to be after I calculate the paycheck amount or before I calculate the paycheck amount? Well, if we did it before, okay, so actually you're right, we could do it either way, so that was a bad question. But if we did it before, we'd have to say, if they work less than or equal to 30 hours, do it one way. If they work more than 30 hours, do it the other way. A different calculation, right? I'm going to do it slightly differently. I'm just going to calculate the paycheck amount like this, and then I'm going to say, if you work more than 30 hours, add 100 to that. Does that make sense? Okay, so really, I'm not telling you anything conceptually now. All I'm doing is I'm telling you how to write what we just said in C++, right? That's an important thing to understand, is that we're just talking about something that's a natural thing in the world and in mathematics. And the very smallest part of that is me telling you how to translate that into C++. That should be the easy part, okay? If, what? If hours worked is greater than 30, then what? Let's get this exactly right now. Paycheck amount gets what? Paycheck amount plus 100. Whoa. Oh yes, I remember this. There's something I need to do here. Editor options. Take off auto. No, I use tab character. Smart tabs.
After it brings the extra curly brace, just go behind and delete the tab.
Well, that's what I did, and then I popped it back in. So I'm going to take out smart tabs and see if that does it. I used to know exactly what to do. Take out smart tabs. And let me try it again. Yep. And see if I go back and try to put it in. It stays there for a second, and then if I hit the enter button, oh no, it stayed. There's still something else that, actually, you know what? I think I know what it is. Hold on. Let's just do, I'm going to get rid of auto indent. Okay? If you like auto indent, you can keep it there, but I'm getting rid of it. So I just have to do it myself. All right. And a lot of actually what we're going to talk about in the next half hour is kind of the style of this and how we structure it. But for now, let me just make sure that makes sense to everybody. Any questions about what's going on there? Basically, let me just say it a little more carefully. Okay, what happens when I encounter this statement, the if statement, is I evaluate that expression. If that expression, now let me back up a little bit. Okay, everyone comfortable with me calling that an expression? Okay. Now in math, usually what you've seen is an expression has a plus sign or a minus sign or something like that, right? And you get a number as the answer. This is just a different kind of expression where the instead of having an arithmetic operator, you have a relational operator. And instead of having a number as the answer, you get a logical value as an answer, either true or false. Okay? So, there's an expression. If it evaluates to true, then I execute what's inside and then continue on with the next statement. If it evaluates to false, then I skip what's inside and just go on to the next statement. Okay? So hopefully that was intuitive anyway, right? You kind of got that idea, but I wanted to say it carefully because you can't always depend on your intuition on these kinds of things. So eventually you're going to see an if statement and it's not going to do what you intuitively thought it was going to do, so you need to fall back on what you know about, more formally how it works. Okay? So let me run this so everyone believes me. If I work 20 hours and it's $10 an hour, I just realized that I didn't put a system pause in here, so it's going to disappear, huh? It should say 200 and it disappeared. Okay, let me put a system pause. Oh, the other thing setting that I like to do on here is I hit that blue line. Highlight current line. System pause. Okay, let's try that again. Hours worked 20, pay rate 10. My paycheck is $200. Okay? Now if I run it again, is it F9? And I say hours worked 35, rate of pay 20, how much is my paycheck going to be? $700? Okay, 35 times 20 is 700. I'll give you a hint, okay? So what's going to come out here? 800, right? Because this person worked more than 30 hours, so they're going to get a $100 bonus. So instead of 700, it's going to say 800. Okay? Any questions about what's going on there?
I have a quick question. Do you have these little brackets around the if statement, or are those absolutely necessary?
Okay, good question. The next thing I want to talk about before I talk more about if statements is some issues around indentation and the curly braces. Okay? the first thing, so that's two different things we're going to talk about, indentation and what to do with the curly braces. Indentation is anytime you have a statement that is part of what came right before it, you have to indent it. Okay, so in other words, this statement here, this assignment statement, is part of the if statement. It's not the next statement after the if statement, it's part of the if statement. So you indent it. It's basically as simple as that. We're going to talk about a lot of different statements, if, while, for, whatever the statement is. If there's statements inside it, they get indented. Okay? Sounds really simple. For whatever reason, I get a lot of really messy, at least half of you will have indentation errors in your programs. Okay? So just try to be real careful about it, and I don't know if it's because students aren't careful enough or if there's something confusing about this. But it seems to be a big deal. So work really hard at getting your indentation correct. The one thing that I notice sometimes is people think, okay, in lecture Dave did an indentation thing when there was an if statement, so that must mean that every time I have an if statement I indent it. So a lot of students will indent the if statement itself. Okay? That's not correct. Because the if statement isn't part of the paycheck amount gets statement, right? It's the next statement after it. So it should line up with it. Okay? Question?
I noticed that you put the set brace on the same line.
Okay, let's talk. We're going to talk about curly braces next. Okay? So the question was about curly braces, and I'm about to answer that. All right, so the truth is, and this is a truth that if I had my way, I would just never let you know, but you're going to figure it out anyway, so I will tell you. You don't actually have to have the open and closed curly brace here if there's only one statement inside the if statement. Okay? There I think it's really good practice to just always use open closed curly brace. A lot of programmers don't, but a lot do. So that's, you can have a philosophical debate about it. But the reasons that I would always put it in is, first, if you go back later and add another statement in there, you're less likely to cause an error because you forgot that now you have to put the open closed curly brace in. Does that make sense? If there's more than one statement there, then you have to put the open and closed curly brace in or it doesn't work. Okay? Let me finish up my reasons here. Actually, the biggest reason, though, I think, is that if you always put open closed curly brace, then all of your if statements look the same. So there's consistency in your code, and it's easier to just identify the different parts. You're going to get some programs where you've got really, a big long if, else, if, else, if, else with nested if, else's, and it's going to be important to try to keep them all straight. And if you put curly braces in sometimes and sometimes you don't, in my opinion, that just makes it harder to keep everything straight. It's easier to keep everything straight if you're just consistent and always put them in every time. The other thing is that if you use this style consistently, it's very easy for me to look at your code and see if you've got too many closed curly braces or too many open curly braces or whatever. Because if you use this style consistently, you're never ever going to have, we don't have any more chairs. I think you could get one from the lab if you want, or you can just stand over there. Okay. If you if you use this indentation scheme and always use curly braces, you will never have curly braces, closed curly braces that line up. The closed curly braces will always be outside of each other. I'll show you that in a minute. And there's some other things like that. I'm not going to try to explain them now. I'm just going to tell you that it's much easier if you use this scheme to keep track and make sure that all of your open and closed curly braces are correct. Question?
Do they kind of serve as if, this, then, that? Because if it's just if hours worked over 30, then what does that mean?
In C++, we just skip the word then, right? So if I'm talking to you in English and I say, if it's raining, go outside. Or I could say, if it's raining, then go outside. They both mean the same thing, right? So in C++, I just don't say then. I just say, if it's raining, go outside.
Yeah, but I mean, like, let's say if you just put if hours worked is greater than 30, that won't do anything to your original.
You said something about curly braces, but if I take the curly braces out, it's the same thing.
Okay. Well, what I'm saying is, how do you separate the hours worked greater than 30 with the paycheck amount equals paycheck amount plus 100?
Because the hours worked greater than 30 is in parentheses.
Okay, so that okay. So the parentheses are different from that. They look the same thing.
Oh, okay. Right. These are parentheses here. Okay. So the condition up there in C++ is always surrounded by parentheses. And then you've got open curly brace, closed curly brace that surrounds the statements that are going to get executed. Question? Will I need to use the braces? Okay, so I might have two things going on in here. I might recalculate the paycheck, and then I might say, see how, congratulations, you got a bonus. Okay? So the question was, can you give me an example of where you would have to have the open and closed curly brace? And there's an example. Anytime you've got more than one statement going on in there. Okay? Okay, I need to tell you that there are different techniques for how people like to do their open and closed curly braces. And I use a different system than what you're going to see in the textbook. And I really, really, really like my way a lot better. So I will not take points off if you want to use the style that's in the textbook. But I recommend doing it my way. But those are the two choices, okay? Either you use my system or you use the system you're seeing in the text. Don't make up your own. So in other words, indentation isn't like, oh, I'm going to try to figure out what kind of makes the most sense here in my own personal opinion, okay? Indentation is you're following a set of rules about how the indentation works. Question? Sure, yeah, you can have as many if statements as you want. They would have to go one after the other, that's right. Question? If I want to, it depends on what I want to do. Are you saying in that a specific example? Okay, so if I wanted to say, you know what, let me not go there quite yet because I'm going to talk about things a lot more, and then if you still have that question, let me know. Okay? Okay, I still need to show you what the textbook's system is for open and closed curly braces. The only difference is going to be that this curly brace is going to go down on the next line right under the if. That's what you're going to see in the textbook. Okay? In my opinion, when you get into some really complicated if statements, and if-else statements that we haven't talked about yet, this becomes more confusing because you've got more things on the left margin. Okay, in my system, the only thing you're going to see on the left margin is the beginning of the if statement and the end of the if statement. And it just gets really spread out vertically too. So anyway, I don't care if you want to use the system from the textbook. That is fine with me. But I prefer to put the open curly brace up on the same line. Okay, there are a couple of rules about the open and closed curly braces that, you know, if you're not sure you're doing it right, you can check it against these rules. And I state these in the style conventions. close curly brace is always going to be the first thing on a line. If you've got a closed curly brace somewhere on a line, not at the beginning of the line, then that's wrong. Open curly brace is always going to be the last thing on a line. So you'll never have something after an open curly brace on a line. Question? No, I feel I don't feel as strongly about it with functions because it's so the question was, do I feel this way about just if statements, or do I also feel this way about functions? The answer is I use the same technique with functions just for the sake of consistency, but really with a function it's not that big a deal because you're not going to have really complex nesting and stuff with functions. Oh yeah, right. So I'm not consistent here, right? No, you're right. If I was being consistent with my style, I would do this. Okay? And probably the reason you've seen it both ways is that for many years I wasn't consistent. With functions I did it on the next line, and with everything else I did it on the same line. And then I thought, well, you know, to be consistent I should do it on the same line. So, anyway. Okay. Let's try changing our program up a little bit here. Let's say this idea of giving this employees a $100 bonus isn't really working out. So instead I decide I just want to give them the traditional overtime kind of thing. So if they work less than 40 hours, they just get straight pay, but any hours that they work more than 40, they get paid time and a half. Question? You're right, these probably should be doubles, but just to be stubborn, I'm going to leave everything as it. Okay? Maybe if nothing else, just to show you that it can be done that way, to make sure you understand ints. Okay, so the question was, wouldn't I need to make the variables into doubles, I think. Okay, so let's go back to what we had before, and let's talk about how we want to handle this. How come I can't? There we go. All right, so, and I'm going to go ahead and still calculate it in the same place. I want my if statement to be right here. So tell me what I want to say. Let's do the easy case first. If hours worked is less than 40? Less than or equal to 40, right? If hours worked is less than or equal to 40. What? Paycheck, amount. Oh, you know what? I don't need this up here, huh? Huh, how funny. I've used the same lecture notes for like, I won't tell you how many years. And there's always been that error in there and I never knew it. I can delete that line. Paycheck amount gets just the basic thing, right? Hours worked times pay rate. Okay, and then I want to say if hours worked is greater than 40, and I'm not gonna spend too much time trying to work this out. I'll just do it for you. Paycheck, because this is not really the point of the exercise. I'm gonna say 40 times paycheck plus hours minus 40 times it's hours worked, yeah. And that's not, equals pay rate plus hours worked minus 40 times pay rate times 1.5. Should be what? No, because if you work more than 40, then I'm saying for the first 40 you get paid at the pay rate. Okay, and then what's left over, the remaining hours that you worked more than 40, That's hours worked minus 40. You get paid at time and a half. Okay? Okay. Is that going to work? Everyone happy with that? Let's give it a try. Okay. Compile and run. And hours worked. Let's just make it easy. Well, let's do 40 and let's do 10. So what should that be? $400, right? Okay. But if we work overtime, so 41. Let's try 50, okay? You makes the math easy? Yeah, I want the math to be easy. And the rate of pay is 10. What's it going to be? 40 hours at 10 is 400, and then 10 hours at time and a half is $15 an hour, so that would be 150 for that extra 10 hours. So it should be 550. Okay? If you didn't follow the calculation, you can sit down and stare at it for a while after class. It should be 550, okay? All right.
Can you just put it down? I missed that little one. If hours worked is bigger than 40.
Yeah, hold on. I can get rid of this now, right? The output screen? Okay. And let's scroll down so you can see the rest of the code there. All right, so what I'm going to tell you now is a better way to do this. Okay. Basically what I'm saying, if I was saying this in English, I might say something like, if hours worked is less than or equal to 40, do this. Otherwise, do this. Right? So in C++, you say that with the word else. So I can get rid of all of this and just say else. And I would probably put a space there for readability.
Is that how you want us to format else?
Yes. That's the good way to format else. Or you can do it the way they do it in the textbook, which would be putting everything down on a new line, okay? So, and I'm going to wish I had auto indent here, huh? The else goes on a new line. That goes on a new line. Yeah, I need to bring my auto indent back. Like that. Everything gets spread out vertically, right? Any questions about else? So basically what that says is that if, so let me explain how an if-else statement works more carefully, okay? Actually, first let me get my preferred, this is going to take forever. Okay, so if, so the first thing that happens is that condition is evaluated. That expression is evaluated. So if that expression evaluates to true, I'm going to execute the if part, and then I continue on with the next statement. If this condition, if that expression is also a condition, but if that expression evaluates to false, then I'm going to execute the else part, and then continue on with the next statement. Okay? Any questions about how that works? Good. Okay. All right. I think I'm done with the paycheck problem for now, but I still have another half hour left in lecture to go, right? So as soon as I said, all right, I think I'm done, I saw about 8 people start grabbing their backpacks. So not done with lecture, I'm done with this example. So I'm going to, I guess I'm just going to go ahead and get rid of it. Okay, I'm just going to do a couple more examples now so we can kind of get used to playing around with if statements. And I will just, let me just tell you in advance that the strategy I'm taking here is I'm sort of okay, there's always this expression here called a condition, right, in an if statement. I haven't said anything at all about how you make a logical expression. So far I've basically kind of just said, well, I want to use the less than, or I want to use the greater than or equal to, and you've kind of intuitively tracked with me, okay? And I'm going to continue that because I would rather give you some concrete examples first, and then go back and kind of say, okay, well here's more carefully how those logical expressions work, okay? So I like to move from the concrete to the abstract rather than the other way around, when possible. Okay, so we will be talking more about those logical expressions. But first, let's write a program that figures out what somebody owes in taxes. Okay, but this is going to we don't want to do this for our own country because it would take us a while. So we're going to have a make-believe country where let me see if I can. I'm trying to decide how to explain this without drawing it on the board. So if the income is less than 20,000, and the person is less than 55, and there's going to be greater than or equal to 55. The tax rate here is going to be 15%. The tax rate here is going to be 10%. And then if they make 20,000 a year or more, the tax rate here is going to be 20%, and the tax rate here is going to be 15%. Oh, that's not bad. Does that make sense? That table make sense? Okay. Yeah, I'm going to run for president. Okay, so what do we need to do here? Let's write this program. So this is good. Finally, after a week or so of all of this abstract stuff I've been throwing at you, we're now back to let's write a program together. Okay, and hopefully that will help you actually be able to go through the process yourself when it comes to your turn to do it, because I'm going to be going through the same process, same mental process that you'll need to go through. Hopefully, that's the idea. So what do we need to do here? We need to declare some variables, right? I would suggest that probably it makes more sense to do that as you are going, because at this point you're just kind of guessing what variables you're going to need, right? So my suggestion would be just start writing the program, and then when you realize you need a variable, go declare it. Okay? So what's the first action thing that really needs to happen in this program? I'm sorry, I couldn't hear any of those. You need to prompt them for their age and for their income, right? So, enter your age. Let me see if I actually have this someplace. Nope. Okay. CN age. Okay, so that means I need a variable age. So I'm sorry, I'm kind of switching my example up on the fly because there's something else here that I could illustrate if I changed that might help you on assignment 3 if I change what I'm doing here. So I think I'm going to do that at the risk of, number 1, confusing you, and number 2, I'm going to set it up so that males and females pay different tax rates, and I hope no one is upset about that. So just remember, this is pretend, okay? And we're going to say that we're going to be, what do you call it when men are let the woman go first? Chivalrous. We're going to be chivalrous, and let the men pay more taxes. So this is the tax rate if you're a male. This is the tax rate if you're a female. Did I use the right word? Chivalrous? Okay. All right. Everyone okay with that? No, I don't care if you're okay with that. That's what we're doing. Question?
So it's no longer senior.
Yeah, I'm no longer doing the age thing. So the age doesn't matter. So I better change this. Enter your gender. CN. Sure, I could say M or F. Okay? Now that means that that I'm not going to have age, I'm going to have gender, right? And instead of int, that's going to be char. Okay so far? All right. So what kind of variable should income be? Let's call it a double. Okay, now what? Let's do gender first. So if gender, okay, equals, if gender, let me just do it wrong first, okay? Don't write this down. If gender equals F, then something here, right? Okay. The problem here, and this is I'm going to give you a sneak preview, and then I'm going to talk about it in more detail next time. But in C++, is that an equal to? No, that's not an equal to. That's an assignment operator, right? In C++, the equal operator is double equal. Okay? So turn your mathematics brain off when you see an equal sign, or when you're trying to express an expression. When you're trying to express an expression. This is an expression. I'm asking whether I guess it would be called an equation, huh, in math. That's an equal sign. All right. What else is going to be a problem here in that logical expression? Yes? Right. So right now, what I'm asking is are the contents of the variable gender equal to the contents of the variable F? Is that clear to everyone? That's what the compiler is going to read, but there is no variable F, so you're going to get a compiler error. Okay? About half of students that I have who encounter this situation the first time don't put the single quotes, do this, they get a compiler error that says F is an undeclared variable, and so what do you think they do? Declare F. Okay, so they go up here and they say car F, and then they run it again and they don't get a compiler error, but it still doesn't work. And they don't know why it doesn't work. Okay? So that's not how you want to fix that problem. The problem isn't that you didn't declare F. The problem is that F isn't supposed to be a variable. F is supposed to be a character literal that you're comparing to the contents of gender. What I want to say is, are the contents of the variable gender equal to the character literal F? Okay? Yes. Character values are case sensitive. So if they enter a lowercase f, this isn't going to work. And I'm not going to worry about that at this point. Okay? We're going to worry about that next time. So if the gender is equal to f, what do I need to do? Am I prepared at this point to calculate their tax? No. I still need to divide them up again, right? So I'm going to put another if statement inside here. Okay? If the gender is equal to f, then I need to say if the income is Let's say less than, to start with, 20,000. Now am I ready to calculate the tax? Yes. Okay, so I'm going to say tax gets what? Okay, 15%, is that right? No, 10%. Else tax equals. Now what does this else mean? I'm still in the part of the if statement where gender is equal to F, right? So this, what I need now is what the tax is going to be if the gender is F and the income is greater than or equal to 20,000. So that's 15%, right? Hey. Okay. Now I'm done with the calculating tax for females, right? So I'm going to close that part of the if. Notice that the closed curly brace here lines up with the corresponding if. That makes sense? And also, if you've got an else, then you're going to have a closed curly brace on the margin for each else that you have. So this closes the else, and this closes the if. Question still or no? I have an extra one. I'm still, well, okay, I'll take it away for now. Okay, so what happens now? So I have another if statement, if gender equals M. No, this is a closed curly brace. This if.
Oh, okay. So it's like.
Okay, so I could create another if statement here, but I'm going to assume that the user is entering either F or M. I'm not going to try to figure out what to do if they enter X for their gender, okay? So instead of having another if statement, I'm going to do the better thing, which is else. And then I'm going to have a similar situation inside here, right? If income is less than 20,000, tax equals, now it's males less than 20,000, 15%. Else. Okay, so that may look like just like a bunch of characters thrown at random up on the screen at this point, but once you do this a few times, it becomes very well structured. Here's an if-else statement, right? Here's an if-else statement, and those are just statements that are inside the big if-else statement. Oh, I have to declare tax. Good point. And then down here at the bottom, I just need to print it out. See out. Your tax bill is tax. First, before you ask any questions, let me just say, I know you may not have seen the fixed and the set precision yet. I think those are in section, did we talk about that before? 3.8, I think it is. You can read about it there. Basically, if you use the fixed manipulator here, then when you say set precision 2, that indicates how many digits are going to show up after the decimal point. Question?
In order to use it, aren't you going to have to include
Include what?
like, are you going to have to include
Yes. In order to use those, I need to # include IO manip. Does everyone just a second? Does everyone understand why I'm putting those there? Okay. If I don't have them there, then I'm going to get 6 digits after the decimal point or something like that. It makes it so that I only get 2 digits after the decimal point. Correct. Question?
Yeah, how would you result they use if the user types anything but S, if they calculate it as S?
Correct. The question was, the way I have it written, if the user enters anything other than uppercase F, my program is going to assume that's a male. Even if I enter lowercase f, yes. Question there or no?
Yeah.
Yeah.
Why is fixed and set precision being used with the string insertion operator? Aren't you using those on the actual value itself?
No, what it's doing is it's actually changing the state of your of the string you're inserting into, so that from now on, whenever I insert something into cout, it's going to have this case until I change it.
Okay.
Question. # include? No, it does not matter which order the # includes are written in. IO manip. It's short for manipulator. Okay, we should run this and see if it really works. Okay, so enter M or F. Let's say M. Well, let me do F because that was the first one, right? F. Income is 10,000. So what should the tax be? 10% of 10,000, which is 1,000. Okay. Let's try it again. Let's enter lowercase f just for fun, because that's going to make it assume that I'm a male, right? And then let's do 30,000. So what's the tax going to be? 20% of 30,000, which is 6,000, right? Okay. Any questions about that example? Let me just say about the fixed and the set precision, I'm purposefully sort of fudging that topic a little bit because I just want you to read about it in the text, and I want to spend a lot of time talking about it in class. So it's 3.8. The other thing I should say is going back to, sorry, I just noticed that someone online is asking what the question was about # include IO manip.
Oh, I asked what's the order matter?
Someone asked if the order mattered. That's the only question I can remember that it was about it. Sorry. Okay, so I want to go back to talking about the extraction operator just for a second here. There's a lot of stuff about reading input that I haven't had and won't have a chance to talk about in here. So that's one thing that you definitely need to, if you're not doing the reading, okay, hopefully you are, but if you're not, or if you are, this is something you should emphasize even more, is section 4.1 is all about different ways of reading input, and the extraction operator is just one of them. Okay, and I will tell you that that comes up more than once on the midterm. Okay, so you really want to be comfortable with section 4.1. Okay, and if you're listening to this and you're not using the Dale textbook, then that has absolutely no meaning to you. Any other questions? Yeah. The question was, where is the IO manip that you're talking about? Anything else that we want to talk about before we leave? All right, that's it.